Hi Year 10, so today we're going to be looking at how we measure the rate of transpiration. So your title is Measuring Transpiration. And we're going to look at a piece of equipment that I've drawn for you here, which is called a Partometer. And a Partometer essentially is a narrow tube of glass. I've drawn it wider than it really would be on here. It's a very narrow tube of glass, which we call a capillary tube. So that doesn't mean it's got anything to do with the blood vessel capillary, it's just called that because it's a really narrow tube. That should say glass there. So with a Partometer we've got this narrow glass tube, and alongside it there'll be a scale that we can take measurements from, and this may just be a ruler scale, and it'll have a clear scale marked on it. And what we do is we fill this tube with water, so everything will be full of water right from this reservoir up here, and we've got, this is like a backup reservoir, I'll explain in a minute what that's for. The whole tube will be full of water too. But there'll be one point where we've introduced an air bubble. And it's really important that that air bubble is there. And this at the bottom is just a beaker with more water in it, so that we can keep water flowing through the system. So this air bubble is the feature that we're going to use to take our measurements. I'm just going to do a black outline on that so it's clearer. So we attach the plant in here. This is passing through a rubber bung that has a hole in it. We might need to use a bit of Vaseline around there to seal off any air spaces. We do not want any air gaps. We want this plant, the cut stem, to be in contact with water, and there not to be any air spaces on a route for air to get in or out. We've then got our column of water through the capillary tube in the Partometer, right down to the beaker here, and the only air is this one air bubble. Now, a plant is constantly transporting water up its stem in the xylem. So we know water is going to be pulled up that xylem, up to the leaves, and then from the leaves water is going to go out of the stomata. So we've got this constant stream of water vapour going out of the stomata in the leaves, and so the plant is constantly losing water. Now, as it's losing that water, it's going to be pulling water up the xylem. So if you remember, we looked at transpiration last lesson. As water leaves through the leaves, it pulls water up the xylem, and that's going to keep water moving through that plant. And so as long as the plant has a constant supply of water, it's going to constantly be moving water in at the bottom and out at the top. And so as the plant's losing water from its leaves, water is going to move along our tube here, the Partometer. It's going to keep moving along all the way, and extra water will be taken up at the bottom here. And what's going to happen as that water moves along, this air bubble is going to move with it. So we will see over time that that air bubble shifts along this tube, and we can measure on this scale how far it moves in a set period of time, and that's how we can measure the rate of transpiration. So we measure the rate of transpiration in terms of the distance the air bubble moves in a set time. So it might be that we measure it for 10 minutes, for example, and see how far it moves. The time you'd use would depend on how quickly that bubble is moving. You might need to make it quite a long time to get a significant enough movement to measure, because this process can be slow, especially in winter. Now, with this practical, you can alter the conditions that you put the plant under. So I could set up a fan here and get that air moving. I'd be simulating high wind levels. That would be moving more water away from the leaves. That would be causing a faster rate of diffusion of water vapour out, and that would increase the rate of transpiration. So if I have a fan set up here, we'd expect the air bubble to move further in that set length of time. I could equally do the opposite and put a plastic bag over this, a clear plastic bag, and that would stop any air movement around the plant, and see what effect that would have. I could set up a lamp shining on this to increase light intensity, or I could put this next to a heater to change the temperature. So lots of things we could change in order to measure their effect on the rate of transpiration. And so with your knowledge of factors that affect transpiration, you should be able to predict what those different conditions would do in terms of the movement of that air bubble. Now, it's really important that this tube is narrow. I said that earlier, and the reason for that is the narrower this tube is, the more that air bubble is going to move in that set length of time, and so it becomes easier to see the change. If I had a wide tube, it's going to take longer for that bubble to move even a tiny distance, and it's going to be hard to measure, and that changes the resolution of the data we get. So the narrower this tube is, the greater our resolution, because I can measure smaller increments of change, and that leads to a more accurate measurement. So that narrow tube means we get more movement of the air bubble, so more movement of the bubble. That means it's easier to actually see a change. It also means that that bubble's going to move further in a set time, which gives us a higher resolution, because I can measure much smaller changes, and that in turn means that I have a more accurate measurement. It's important to say that it's the measurement that's more accurate, not the experiment, because narrowing that tube doesn't alter how this works. It only alters the measurement that I take, the resolution of my measurement. Okay, so that's all you need to know about photometers and measuring transpiration.